Alrighty, welcome back boys and girls. It's your main math man, Mr. Shen, coming to you live from Alameda International High School. In this video, we're going on some trig word problems. So make sure at the very top you put your name, but also too you can put that SOHCAHTOA. That way your trig identities are easier to remember. So again, it's going to be sine is equal to opposite over hypotenuse, cosine of theta is equal to adjacent over hypotenuse, and the tangent of theta is equal to the opposite over adjacent. So you're going to be using those for these problems. So in that first one, it says this. It says the famous Leaning Tower of Pisa leans at an angle of 4 degrees and is 55.86 meters off above the ground. Determine the height of the tower when it is originally built. So a way you can draw the picture is like this. I could say, all right, I want to have a right triangle. I could say, all right, it's currently 55.86 meters off the ground. I'm looking for that original height x, and I'm gonna say this angle is gonna be 4 degrees. So when you go to label your right triangle, you can say, all right, opposite of that right angle is the hypotenuse. I'm gonna say this is angle, or this is side H. I have my angle theta, side opposite is gonna be called O, which is opposite, and that side next to it is gonna be adjacent. So that means when I go to pick my ratio, I can say, okay, I have the A and the H, so I'm going to use cosine. So I can pick my ratio as cosine of theta is equal to adjacent over hypotenuse. And I sub in my values for my variables, and so I could say, all right, the cosine of 4 degrees is equal to 55.86 over x. And so now when x is in the denominator, this is when you have to do 2 steps, because I need to get x by itself. And so I'm going to multiply both sides. So when I go to solve, I have to multiply both sides by x. So this is when I multiply both sides by x. And so now I have x times cosine of 4 degrees is equal to 55.86. And the reason why we're doing this is because these x's cancel out. We're trying to get the x by itself. Last step, divide both sides by that cosine of 4 degrees. And so you should have x is equal to 55.86 divided by the cosine of 4, which let's find out what that is equal to. So we have 55.86, again, make sure you're floating and you're in degrees. So I have cosine of 4, that's gonna be equal to, we can say 55.99, we can say meters. All right. So now for number 2, it reads like this. It says you are standing 130 meters away from the base of Alameda International High School. Determine the angle of elevation of the top of Alameda that is 58 meters tall or high. So I'm going to say, all right, draw the picture. So I can say, all right, I have my right triangle. I can say I have a right triangle since it has that right angle in it. I can say, all right, it's 58 meters tall, and I am standing. I'm standing over here. I'm looking up, so this angle theta is going to be that angle that we're solving for, and we are standing 130 meters away. All right, so go to label that right triangle. Side opposite the side opposite of the right angle is the hypotenuse. Side opposite of the angle theta is called opposite, and my adjacent side is going to be 130 meters. So when we go to pick the ratio, again, we're saying we have opposite and adjacent, so that means we're going to use tangent. So the tangent of theta is going to be equal to opposite over adjacent. Sub in my values for my variables, and so I could say, all right, angle theta is equal to, let's actually take a step back. We could say tangent theta, because that's what we're solving for. We have opposite, which is 58, and we have adjacent, which is 130. Again, you use the inverse operation, so I have to do the inverse of tan. So I have like this, I have theta is going to be equal to tan to the -1 power. Still the same ratio, 58 over 130. And so I can say, all right, second tangent of 58 over 130 is going to be 24.04 degrees. All right, and then at the bottom, it says this, it says Marita is flying a drone that makes a 50-degree angle with the ground. Determine how high the drone is above the ground when it has flown 150 meters in a diagonal line. All right, so again, draw that picture first. So I'm gonna say my right triangle. Again, be careful when you're drawing those right triangles. That is the trickiest part. Again, make sure you can do practice with it. So we're gonna say, all right, here's Marita down here, and she's looking up at that drone at a 50-degree angle. We're saying it flew 150 meters, and we're trying to figure out how high off the ground it is. So again, we can have our picture, go to do your labels, and so it has side opposite of the right angle is the hypotenuse. Side opposite of the angle theta is 50 degrees, which we're going to say side x is going to be opposite, and that side adjacent is going to be a. So since we have O and H, we know we can use sine. So again, if you need to write at the bottom for yourselves, so katoa, please do. That way it's a little bit easier to remember. So again, I have opposite and I have hypotenuse, which means we use sine. So I pick my ratio. So I have sine of, let's do lowercase, that way it's easier. Sine of theta is equal to, we have opposite over hypotenuse, sub in my values for my variables. So I have sine of 50 degrees is equal to x over 150. Again, make sure you can get x by itself. So we're going to say, we can multiply both sides by 150. And so we have, when we solve, we have x is going to be equal to 150 times sine of 50 degrees, which let's find out what that is. So we're going to say it's going to be about 114.9 meters off of the ground. On the back, again, make sure you can have SOHCAHTOA first. Again, you can write it as many times as you need to, but at least write it once. Right up, even at the bottom. All right. So for number 4, let's make sure this is in the picture. For number 4, it says this, it says you assert your domination over a friend and you T-pose right in front of them. Say you are 1 meter tall and you cast a shadow that's 1.3 meters long. Determine that angle of elevation of the sun. So, you can draw that picture for yourself first. So that picture, I'm gonna have, pull check, make sure it's in there. All right, so I have my right triangle. We're looking at the sun up here. Something like that, maybe. Whatever works best for you. But you are trying to figure out this angle down here, which is theta, and you are T-posing right in front of them. And so you're casting that shadow that's 1.3, where you are 1 meter tall. All right, so go ahead and do your labels. Side opposite of the right angle is the hypotenuse. We have opposite of the angle theta is side opposite, and that 1.3 is going to be adjacent. So we're going to pick our ratio. I have opposite and I have adjacent, so we're going to say I have tangent. So of theta is equal to opposite over adjacent. Sub in my values for my variables. So I have tangent of theta. It's going to be 1 divided by 1.3. And I need to take that inverse operation. So again, make sure you say at angle theta when you go to solve it. Angle theta is going to be tangent to the negative 1 power, 1 over 1.3. So I have second tan to get that inverse operation, 1 over 1.3. So I'm going to say it's going to be about the angle amount is going to be 37.57 degrees. All right, so now for this next problem, for number 5, it says a ladder that is 6 meters long is leaning against the side of a building, making an angle of 6 degrees with the ground. So first we need to determine how far the ladder's base is from the side of the building and how far up the building is. So again, you're solving for 2 missing sides of the right triangle. So we can say, all right, I have my right triangle. I have this building on the side here. So I'm saying this ladder is 6 meters leaning against it. So notice how you kind of looking down the side of a street, you're saying, okay, this is your building on this side here, and you can say, all right, it's leaning against it. It's making a 60-degree angle, and so let's find out what we can solve for. Well, so I have my picture. And I'm going to do my labels now. So I can say, all right, side opposite of that right angle is going to be the hypotenuse. So I have one of those sides already. However, I don't have the other missing 2 sides, those 2 legs, but we can at least label them now. So I'm going to say this side opposite of 60 degrees is going to be our side opposite, and we can say that's going to be labeled as X. And then we can say our adjacent side is going to be labeled as Y. And you can use whatever you like, but as long as you have those 3 sides labeled, you will be good. All right, so first we're going to pick this ratio. I'm going to solve for X first. So I'm going to say, okay, I have O and H. So I'm going to say, all right, pick a ratio. I'm going to say sine of theta is going to be equal to opposite over hypotenuse. Sub in my values for my variables. So I say, all right, sine of 60 degrees is equal to X over 6. And when I go to solve, I can say, all right, X is going to be equal to, I'll multiply both sides by 6. I have 6 times the sine of 60 is going to be equal to, I have 5.9. So I'm going to say X is going to be equal to 5.196 meters. All right, but make sure you're saying, okay, 2 missing side lengths, so I need to solve for X. So again, to go back to picking my ratio, I have adjacent hypotenuse, so I'm going to use cosine this time. So I have cosine of theta is adjacent over hypotenuse. Sub in my values for my variables, so I have cosine of 60 is equal to Y over 6. And so I'm going to say multiply both sides again by 6, just like before. So I have Y is going to be equal to 6 times the cosine of 60. And so I have Y is equal to 6 cosine of 60 be equal to 3, and then 3 what? You say 3 meters. All right, so your 2 missing side lengths are X, which is 5.196, and Y is 3 meters. And we know this actually works out because we said, hey, we have this hypotenuse is 6 meters. So that means when I go to get these 2 answers, they should be, and they have. And for that number 6, it reads the Red October is on the surface of the water. Its radar detects an enemy submarine at a distance of 238 meters away underwater at an angle of depression of 23 degrees. Find the depth, meaning how low it is, of the enemy submarine before their captain destroys you. So you can draw a right triangle, something like this, and I can say, all right, right triangle, I know it's 238 meters away, an angle of 23 degrees. 23 degrees, 238. So I can say, all right, that's that submarine, Red October, good movie on Netflix. I can say, all right, here's my picture. I'm trying to figure out how far down it is. Well, I can say side opposite of the right angle is my hypotenuse. The side opposite of my angle theta is going to be side opposite. And that means adjacent is not the one we need. So we have our labels. We have, for our ratio, well, what two sides do we have? We have opposite hypotenuse, and so that means we're going to use sine for this one. So we're going to say it like this. All right, sine of theta is equal to opposite over hypotenuse. And so I can say, all right, sub in my values. So I have the sine of 23 is equal to x over 238. Make sure you can, when you go to solve, multiply both sides by that denominator. So I have 238 times the sine of 23 degrees is going to be equal to x. So 238 and sine of 23. So I'm going to say it's going to be about 92.994 meters away. Or excuse me, not meters away. It's going to be 92.994 meters down. So again, we were looking for the depth. So how far down was it? It was that far down. Again, make sure you can set up those pictures carefully and super slam that subscribe button.